Hello, good morning. Hello, Mario Dival. Hope I pronounced that correctly. Good morning. Let me. Apparently, my Twitch was resetting the chat room every like 5 seconds, so I got a bunch of welcome to the chat rooms. That's fun. All right. Today we're going to be doing something slightly different, at least to begin with. No, don't download that. Ooh, am I logged into GitHub? I'm not logged into GitHub on this account. That's too bad. Let me pull this window out, and we'll go on this one. So, we got a pull request on the improve skills by building an ECS library in Rust, which was the first course that I did a long time ago. It's my desktop background. Hold on. Completely blank. Yes. I don't know why, but some years ago, I switched to a blank background, and I feel like my productivity jumped. I feel like using images for backgrounds was just, I don't know, distracting me for some reason. So I just went to a blank background. There was a period of time where I just did a pure black background too, which was interesting. Also, good morning, Stacking. Hello, Wally G. You recently started learning a new programming language called Rust, and the truth is it's very challenging. You come from languages that are very high level, like Python. I want to ask which programming language would be more suitable for cyber and information security, Rust or Golang? So it's an interesting question because I can come from one side of cybersecurity, which is more of like the systems administration side, and working with security admins. And in that side, it doesn't really matter, because what you're doing is you're building tools to protect computers and services and systems. And in that case, it doesn't really matter. And here's the thing about like security people. And I know you just mentioned like, hey, you need a language with more libraries. Do you? Because most security people that I know refuse to use them, unless they looked at every little bit of that library to make sure that it was, didn't have any insecurities, any like secure problems. So a lot of them built everything on their own, or would like have to go through line by line to check to make sure it didn't have any security vulnerabilities themselves. So in that case, you might be able to like be slightly safer with Rust, but at the same time, it's hard to tell. You'd want somebody that you can trust to vet those libraries. And if you don't know of any security companies, you don't know where to file, which I don't know where to go, so I have no idea how to like know whether or not a library is safe or not for security use. So if I was to build everything from scratch, I would probably use Rust, because then I get the added protection of the memory safety. So I'm not going to add any more vulnerabilities in. Because you know how reinventing the wheel has worked so well before. I know. Bugs, who writes them? I mean, who write? Yeah. I mean, I'm pretty sure ChatGPT writes all the bugs. They got into Git. They somehow pull requested in. They had a bug that doesn't show the pull request, but I'm sure that's how they got them, right? Anyways, that's my completely like no information, no knowledge answer. Is I would choose Rust because I like it, and because of the memory safety thing, and if I'm going to have to write a bunch of stuff myself, that's what I would do in it. That being said, I would reach out. So, is there a community of developers nearby you? So I'm in Colorado, specifically around Denver. And in Denver, there is a Denver Dev social sort of Discord group that has a bunch of us developers. in it, and there's an entire security channel with people chatting about security in it. I would reach out to them if I had questions and ask them that, because I'm gonna get probably a better answer than me. So if you could find a local group near you of developers, you might be able to then find some security experts that you can ask to. And if you can't do that, then I would be continue going online. I don't know of any security groups that are just sort of like not location dependent. So I can't help you there, but maybe there's some other people around that can help. But I don't know who they would be. So I hope that I help a little bit, but I know it's not a super helpful answer. So sorry about that. All right, today we are going to be looking into the improved skills by building ECS library in Rust course. Specifically, we got a pull request for it. We got it June 20th, but for some reason I didn't notice it until like 2 days ago, which is really unfortunate. So I'm super sorry, Victor, about taking it so long. Victor actually deleted it 2 days ago, which closed the pull request. But I'm reopening it because I think it's a good idea. We should at least look into it. So, Victor's suggestion is that we change the ugly 2u32 to the power of 2 or power of whatever as u32 to the bit shifting method and entities register component function. It looks better and is about 6.8% faster. Basically measuring this way. I don't know if I can do a speed test to verify, but I'm happy to make the change. So files changed, only this one. So we look in the entities folder. Now I'll do a video of me updating this if it works, and if it passes all the tests. And we also have to understand how it's working too. So previously, and let's actually go open up the project because it's been a while. So first of all, let me make sure all the tests pass. I apparently have left some very nice, very professional of me. I left some warnings in here. That's great. So that's in language. Oh, it's in a test. So test language default and test language filter map. Interesting. Okay. Test language default. Okay, so it's never constructed. Let's give a. Oh, do I do it here or up here? I think I do it up here. So allow dead code. And then the other one was the filter map. Okay, so that should make you happy. And then if I remember correctly, all the tests were passing. Let's go ahead and rerun them again in here. This is a new window, and I didn't have the side little bar, so we'll have to handle not having those over there. All right, cargo test. Run you again. Everything is good. Okay, great. Next up, let's see if I can pull in this system. Okay, so I want to test this locally. Can I find this? Is this a branch? Can I like do a... I don't think it's considered like a branch, right? No. I can get the commit, right? Get switch to you. Get checkout to you. Oh. Okay. Oh, is it because... It's because the head repository has been deleted, but we can see what was going to change here. And I guess we can just recreate that ourselves. So let's create a new branch for this. And we're gonna call this... I'm gonna call it the same thing. Give credit. And the idea was we'd go into, this is entities. Okay, so here we have this bitmask 2U32, and we get the power of however long this is, and then convert it to an as U32. So this is being replaced and removed. And then we're going to change the insert here, the mass, bit mass insert, where it's instead of type ID and then this bit mask, we're going to replace the logic in here where it's 1 shifted to the left by self bitmask length, which is so much easier. So 1 was it the bitmask dot length, something like that, right? Yeah. So all right, we got that saved. Let's run our tests again. Does that still work? Oh yeah, it certainly does. Okay, I need to remember exactly how this works again. So if I remember correctly, the ECS system, what's happening here is that we're finding, like, we're registering a component. So I may need, we'll go, where do I want to go for this? I need to sign in. Oh, I don't have the ECS one anymore. Oh, that's too bad. Okay, so we're going to create a new freehand. And we'll call this ECS. All right, so freehand is an excellent whiteboard. I've got dark reader on, which then turns it into a very dark whiteboard. Unfortunately, the CSS isn't really set up for this, so I can barely see what I'm working on, but we're going to make this, how about bright green? That should be very visible on here. Okay, so for those of you who are following along who have not taken the ECS course, and don't know what I'm talking about when I say ECS or what we just did with the bit shifting thing, we're going to go through it right now to make sure I understand it fully. So, not, I was going to say not the, but there's no H. Nataline, hello. Looks interesting. Oh yeah, ECS is fascinating. I love thinking about it because it's such a cool idea. So here's the 5-minute introduction to it, maybe less than 5 minutes. We're gonna have a vector of things in here, and each of these are gonna be components. So we have a component. Typing with a mouse is so hard. I have a Wacom tablet, but I don't have the USB cable to deal with it. So maybe this is component health. So we have an entity that has 100 health. Perfect health. Maybe like out of 100, they have 100. They have another entity that has 95 health. They have one that's like 0 health. That would be dead. Maybe another that's at 5 health. One that has that magic pixel, and maybe these don't have any health whatsoever. They're entities that like just can't be damaged or killed. Then we might have a component. Let's change the colors for this. I'll go to yellow. That might be. Hopefully it's distinguishable. And so this one we have like health. Maybe we have like a location. Man, my writing here sucks. Sorry about that. So location would be like a tuple of X and Y, right? So we have maybe you're like 57 and you're like 100 negative 10. So basically it's an X and it's a Y. And all of these have a location. And for every single one of these on a vertical line, oh my gosh, that was terrible. Let's try that again. If you take a vertical view through all of these components, and you could have a lot of them, these are entities. So player, this might be the player. This might be, I don't know, an enemy. This is another enemy, another enemy, another enemy. This is maybe a block that you can stand on. And every time that you have something that you want, like as part of the entity, the game object, the thing that you're doing something with, you then add another row here. Now, the idea why you do this instead of creating like a class that has all this information in it is because when we load up the class, there's a lot of different objects. It has stuff spread all throughout the memory. And when you go and we say, okay, we're going to update the location of every single player, we're going to update one little bit of memory here, one little bit of memory there, one little bit of memory there. And it gets really slow. Now, the ECS system I do doesn't solve this perfectly, but it's a lot better than like the normal class-based system. So this is solving a problem called cache missing. I think is what it's called. So usually what's going to happen is we want to update all the locations at the same time. So give me the location of this entity, and also give me a velocity of this entity, give me, their something else, and I'm going to do some math on it and then update the location. And then later on, give me the health of the player and also give me like the location of like any bullets on the screen. And then I'm going to do some math to determine if they got hit and then update their health. So if I grab, let's do another color and see, I'm going to choose purple, this one. If I grab this item here, I rarely, like the computer won't actually grab this one item. Instead, it's going to grab a chunk of them. So I want this one, but I'm actually going to get a bunch of them. And the reason for that is because the CPU knows, hey, you're probably not going to want just this one. You usually want a bunch around it. So we're going to give you this one plus the next X of them. And it fills up the cache. Now, it doesn't actually like fill it up to capacity, but it has this cache on the CPU, and it's going to put this data in there. And we can do that for multiple of the vectors. And now when I do data updates, it's going to load them all up in memory, and then I don't even have to go to RAM to load up like the next one of these. I go straight to the cache. And talk about speed. The cache on the CPU is one of the fastest things you can read from. Memory is actually really slow when it comes to game development. And if you have to like stop and pause and wait for memory to come back, you will lag out the player. And it's really fascinating how like in game dev, we're talking about insane speeds that we just don't need to worry about in any other kind of development. So this entire code is all about registering a new component. So, okay, I have a new component here. I want to add something on. But what if, for example, this entity is dead? In that case, I just want to reuse this component, this entity, and I want to like add a new component in like this one correct spot. Although in like this one, I think this is actually slightly different. This is, so when registering a component, I want to insert into bitmass. And so here's bitmax is just this hash map of the type and then the length. Oh, it's the next register. So then the next thing is, let's talk about this thing and what you're doing. So I'm doing some bit shifting fun stuff in this library to make things much, much faster. I initially built the library and we didn't do any bit shifting whatsoever. And it was okay, it worked, but it was slow. My Asteroids game, for example, if any of you remember the Asteroids game that I made and we played, it's very, 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 very slow, especially when it tries to delete components. It has to go and search through them and find them and delete them. And we switched to bit shifting for the course, and that sped things up by like 100 times, maybe more. So, how does bit shifting work? Let's say we have, where's my text? I want 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 27, 28, 29, 30, 31, 32. This is a 32-bit binary number. It's long. There's 32 bits in it. So I am using 32. So it's a U32 here. Should tell us that we can have 32 different components added in. So I can have 32 of these rows. I know that some games have way more than that. And I think they can go up to... There's libraries that let you do U256s. So 256-bit numbers, and that would allow you to have 256 components on, which is absolutely insane from my point of view. But if we're talking like a AAA game, that's also not that surprising. Like, there's a lot there. Okay, so if I were to do something like that, this represents the number 1, right? So, okay, I want this here to represent this component. So I'll put that there like that. To make it really, really easy and understandable, I want this next one to be just the next bit over, and you represent this component. And so on and so forth. So we keep on shifting this one bit that's active over to the left for each new component, so I know exactly which one I'm going for. So if I say I want, this component over here, I can just grab it and I've got it really easily. So what I was doing previously with this bit shifting thing here, I wasn't doing bit shifting. I was just saying, okay, give me, calculate out the number that would have the correct one, wherever it was. So in this case, I have 2 components. What was it? It was 2 to the power of however long this was. So I have 2 components, so 2 to the power of 2 is 4. So therefore, set that, so that's 1, 2, 4. That's what it would be set at, and as you can tell, that's exactly what we want. We now have the next third one. But there's a faster way. What if we just took the previous one that we have here, although in this case, we just get the length here, and we bit shift left like this. Now that double sort of less than sign, that's the bit shifting sign. So let's go. What is the playground? Play.rust. It's been so long since I've been there. I'm just going to add this to a pin. All right, so let's start with like any number. So if I start with, let's say 1, a 1 U32. Thank you, Basilisk. Play Rust playing. Yes, I keep on forgetting that. But I've got it pinned, so I'll be good. All right, so obviously if I debug, I need to give this a variable, don't I? This is our like bits. Run you. This is not going to be happy with this zoomed in, is it? Keep on forgetting how slow this is too. Wally, you don't need to code with bits. It's mostly due to like exactly what I'm doing. That is the problem. What are you upset about? Oh, because of that. I don't want to return whatever debug gives me. But yeah, in this case, bit shifting and like playing with bits was actually the right answer. And so it's not often that you need to actually like pull out the computer science stuff. It's like often been really slow for me, like whenever I use it, especially on stream. So that's not helpful at all. Okay, hold on. Oh, it timed out? Okay. My bits. Oh, right, because I changed. No. Yeah. Can I do this now with print line, or is that just format? Oh, you're coding network and exploit tools for apps and web? Oh, that's fun. Oh, I mean, that makes sense with the security stuff. Yeah. And yeah, well, there could be an argument for like doing weird things like doing a bit shift and then sending that off and like seeing whether or not it causes a crash. But probably not on web stuff. All right, so what am I doing wrong? Why is this not working? So let my bits equals 1. Okay, let's try this. We have my bits. Okay, there we go. So now we have 1 as the standard output. So I want to now, yours says bits equals 1. I don't know what I'm doing wrong with debug. That is so weird. Do I have like some weird config from edition 2021? Yeah, maybe. Possibly. Well, this works, so it's a little bit faster, so I'll just take it. Okay, so if I have this as 1, let's do let my shifted bits equals, I want 1. What is it? It's yeah, it's 1. We're gonna shift by 1. Shift over from 1 U32. HBO 30. Hello. Interesting. Well, it's not really a technical question, although it's only 10 points. I will. Wait, how do I refund that? Oh, I don't even know how to find that thing. Oh, the reward queue. There it is. I want to add that. Refunding you for those 10 points, even though you probably have way more than that. Because I hardly ever get those. Okay, so let's try this. We're gonna shift left bits by 1. So I want to print line my shifted bits. Let's run you. And so we have 1, and then we have 2. So what happened? Well, we took this 1 here, and we say shift it by 1. Well, what is 1? 1 is also this number, right? So shift by 1, and it moves it over this way. So it moves it by 1. What if I try to shift it by like this, by 2? Where's my, what browser am I on? I'm on this browser for it. Wait. Now I'm confused. Where's my stuff? Oh, it's here. I got confused by the lack of a little icon there. All right, so let's shift by 2 and rerun this again. And now it's in the 4 position. So if I shifted left by 2 here, it moved it to over here. So it's 1, 2, 4. So these 2 shifted by this moves it over here. Interesting, right? And it's the number of shifts to make. So let's say I want to go to all 32. So can I do, if I do, let's see, if we start here, so I want to shift by 1, it goes here. So I'm starting here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I want to go to 10, that would be right here. And let's also try to calculate out what this would be. If any of you haven't done binary math, it's a very interesting field. So we would start, this is 1's position, 2, and it goes up by powers of 2, right? So we have 4, 8, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I don't remember if it's this one or this one. Oh, right, because if we start here, we shift over 10 times, we're going to end up here. So this is 8. 8 times 2 is 16. When I was a network admin, I had to memorize all of these. We had to use them all the time. 64, 120. Oh my gosh, I cannot type this. I need to zoom in. 128, 256. That's usually when you have to stop with ours. We don't really care much over that in networking. 256 times 2, so 12, 10, 4, is that 512? 512. 512, so this is gonna be 1024. Okay. So it should be 1024, right? Let's run it. It's thinking. Oh, 20. Okay. Well, that's clearly. Oh, is it by? All right. The bit shifting is not what I was expecting it to be then. If it's only 20, that is different than what I was thinking. So I interrupt you, but continue what you do. I don't know is these points if they're good for you. If you send them. By the way, you're web dev. Oh, nice. Okay. Yeah, so I am currently, so previously I built a course on, let's see, where is it? Improve your skills by building an ECS library in Rust. And so we got a pull request to switch to this for inserting, registering a new component. So I wanted to fully understand it before I push it in. We made the change, we ran the test passed, but I need to like remind myself because it's been years since I've done the bit shifting exercise. Okay, so it's this thing here. So this was 20. 20 is not any one of these things, you notice. But if I find out 20 would be a combination of 16 and 4, or let's see. So if we do 16 and 4 would do it. Okay, can I? There's a way for me to also like show the binary, but I don't remember how to do that. be that. I do 8, there's 12. Yeah, so it actually has to be this one. So what we've got is and then the rest of them are zeros. That's what we ended up with when we shifted over by 10. So we started here with just this one, and then we shifted to the left by 10, which would be not moving air like I expected it to be. Now, if I shifted over by 1, that was 2. So that did it the way we expected it to. If I shift over by 2, that gives me 4. Okay, so that makes sense so far to me. If I shift over by 3, I would expect that this should now be 8. Crosby, hello. Do Rust have binary format number? My guess is, oh yeah, I could binary print that. Let's try it. Let's actually do this. So then it's 6. Okay, so that's different. So shifting by 3. Let's try this. I think you're right. I think this is how we display binary. Or not? Oh, right. It's can I do positional argument like that? There he goes. Okay. Oh, so interesting. With 6, it's now 1 1 that. So I'm let's see. What am I doing with this? I am. All right, let's go and remind ourselves. Rust lang. I want that bit shifting. Let's go find the documentation for it. This isn't the same as the shifting operator. Interesting. Okay. So there's this rotate left and rotate right, which is slightly different, but that was, oh, there's so many of these. Interesting. There's a lot of these bit shifting as the types. But okay, so if I look at 3 is represented as 2 and 1, so it's that would be okay. Different color. I think purple is safe. So that would be I took this original and then I shifted left by this, which gave me 3, which resulted with this and this being set and this being unset. Thank you, HBO. This is the first time you've seen Rest Code. It is definitely interesting. It's relatively new, so I'm not surprised it's not famous in the community you're from. But hopefully, whatever you're working on. Let's see. No, it's fine. Thank you, HBO. Okay, so I think the bit shifting, what's happening is it's opposites. So your 2 are setting to be 1s because you were 0s, and you become 1s here. You were the same, and therefore you become a 0. Pretty sure that's how it works. So just to make things a little bit less confusing, let's go like this. We start with you. We start with you. I'm going to shift by 3, which is that. And the end result now is like that, right? So if I'm going to shift, this is 1, 3. Let's see, this is, no, that's not correct. So eraser? No, that's not eraser. Ah, what did I do? Dark Reader's still on. Okay. Oh, wow. Okay. Undo. Okay, thank you. But 3, that is not 3. That my math. That is 3. So I bit shift like that, and then this becomes 6. Oh, I moved this. Okay, so I moved the left hand operator over by the amount that it was. I didn't move the right hand operator over by the amount that it was. I think, okay. That was the confusing part then. When I put 3 on the left, so this should be the opposite way. What we're working on is 1U32 left by 3, left by 10, and that should give us the 1024. There we go. So I had it right in my mind, but I flipped around the operations. So we shift this number left by this amount. And it's, if you look at it in binary, it's pretty simple. We're just taking this number here. So if we go, we make you a 10. So 10 would be, it actually doesn't care about this. So I want to shift by 10. We take this number here, that's that 1. View, let's duplicate you. And I need a few more of you. So what is this? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then I'm going to take you and I'm going to shift you over by 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's our new number after running this calculation on it. So is this really helpful in day-to-day programming? Probably not. But it's helpful in something where you need like super fast calculations with basic number, because CPUs are basically made for this. Okay, so that's the reason why this works, is we are now shifting just the number 1 over by the length of this, and then that's a new number to insert. So perfect. Okay, so I want to create a quick video on making this change here, specifically on the pull request. So shifting to the left is like multiplying with 2 to the n. Yes, exactly. So if you ever need to do 2 to the n, bit shifting is actually going to be significantly faster than literally anything else that you could do. It is one of the fastest operations you can do on a computer. So let's see, if I have you, I want to just come down here, and then I can do pen colors with purple, and that's fine. Okay, so I'm gonna do like, this is gonna be a fast video, and yeah, we'll have to figure it out. So, anyways, let's mute our music. Oh, come on. No, mute, please. Wow, my Stream Deck is super laggy. It took like 5 seconds for it to mention that it was to update. Okay, so we've got that. Everything else is going. Oh, I'm gonna turn off the chat. Oh, that's up there. Chat, you go away, and then it's just me with this, and this will be fine. And so I'll jump from here. Start with you. And I'll jump with you over to this, and we'll do whiteboard stuff. All right. So let's try this. Let's see how it goes. Hello, and welcome to another addendum for the improve your Rust skills by making an ECS library. It's been a long time, but we got a pull request in for the course, which improves something, and I want to go over what it is really quickly and why it is good. So thank you, Victor Janecki, for the pull request. I'm so sorry it took me so long to get to it. For some reason, I didn't get a notification from Git about it until just a couple days ago. So let's go over what this is. The idea is that when we're registering a component, we are going to change the method that we're setting the bit mask for what that component is. So previously, what we were doing is this line right here. We're figuring out what the bit mask is going to be. We take a number 2, and we get the power to the length of the number of bit masks that we already have. Set that to an ASU32, and then insert that into our bit mask hash map. that's pretty slow, like compared to what it could be. So let's take a look at what this answer is. We just go straight to inserting the bit mask into, well, bit masks, and we just use the number 1, like a literal 1, and we bit shift left by the length of the bit mask vector. And that's going to make it so that we now have, it's going to do to the power 2 of whatever we're going for. Let's look into exactly why this works. So I have a whiteboard here. I'm using Envision's freehand for this. Love the tool. And I've got dark reader on, so that's why it's all black like this. So we're going to use purple. So let's say we have a number like 1. So 1. So this is 1 in binary. Now, whenever we're doing a bit shift, so I want to bit shift by some odd number. So let's say a bit shift by 1 here. What is that going to do? It's going to, so we're going to take this, I'm going to duplicate you. It's going to take this number here and then move it left along the binary by the amount that we're bit shifting by. So in this case, bit shifting by 1, we move you over 1. So you go like that. Okay, that seems pretty easy. What if we do more of them? Well, I bit shift by, let's say, I don't even have 10 numbers here. Let's not do 10. Let's do, how can I change this? Let's do 4. So in that case, if we start here, 1, 2, 3, 4. And if we look at what this number would be, we have 1, 2, 4, 8, 16. So 1 bit shift left by 4 is 16. We can actually go to the playground and play around with this. So let's do, we have my bits, we're starting with 1, we have my shifted bits. So this is, we're going to do 1 shifted by 4, and we expect to see 16. And that's exactly what we see here is 16. And so coming back to our code again, this is a clever way of setting what the next bit mask is going to be. And as Victor mentions, this is significantly faster, 6.8% faster when we're creating components. Not necessarily a problem on the initial load of the application, but if we need to dynamically create components in the middle of the run, this could be extremely helpful. Anyways, I wanted to show this off. Sorry again, Victor, for taking so long. I'm going to get this into the code base and push it up and then get this video in there and live. Thank you so much for watching, and I'll see you online next time. Bye. And it's been forever since I've done a video in that repo. Okay, so let's get this going. We've got you all happy, so all the tests are passing. I don't have anything there, so let's quit out of you. And all right, so I guess those other ones were me. Okay. Git add tests. This is fixing warnings. And then we're going to do a git add. All right, so this one we want to give credit for Victor. So implementing, I can do this in a comment, right? I think that works. Keys, PR. Let's see. Do that. Now I have this as part. Okay, I'm in here. So let's. I think I can just merge this in with main. Get switch to main. Okay, and I'll get push you up. I think that this will now show. Yeah, there we go. Oh yeah, and it shows right there. So now that is immortalized in here, which means I can now take. Can I see this commit? All right, so I couldn't check out the code, so I re-implemented, gave you credit in the thanks again. I don't know if I can like do something like that. That doesn't. I don't think that works. All right. Okay, so that is that. That's 8:06. We spent all morning doing that. Oh, we have release notes for this. I totally forgot about that. Sure. All right. What do we want to install for Markdown? Marksman? Probably not Grammarly. Probably not. I'm guessing the LTeX is for latex. I don't want that. Remark and Tailwind. Those don't feel like they're appropriate here. Remark is for like creating some kind of like a visual display out of it, like a presentation. Never heard of ZK, so maybe I'll do Marksman. Okay, so 104. I mean, I could also probably create a release for this too, which would make sense. This is implementing a it's not really a fix, so implementing an improvement for inserting components by calculating the new bit mask with a bit shift. Thanks. Do I have? thanks. Oh, perfect. I think I can just do that. Thanks. For the PR. All right, so if I take you, so updated README. Okay, so what I want to do: GitHub release, create the 104. Title. This is improving component insertions, registration, improving registering component speed. Own, and then I just want this. Nope. Publish. All right. Now we actually have a release for this too. There. So credit all over the place. That's good. Okay, well, that is the ECS library. If we were to come back to our LMS system, I don't think we really have much time to go over everything else. Last we left off, we have tests set up for everything that we care about on the front page, I believe. So we have tests for Discord. Then we go to courses, and we have tests for clicking into a course and going to the course page. So I think the next thing is to continue looking through the design. So course library, we have this. Clicking to it takes us to there, so that's good. Is there anything else in here that we need? I don't have course bundles for right now. I don't have an advertisement yet. I don't necessarily have learner support. I'm probably going to start without this in there, and then we'll add it in. I don't really have support up yet either. So then, yeah, we're kind of done with this. Then we move over to this one next time. So, on to here. And that will be, because it's 8:12, not really enough time to start working on something if we're going to end it in 3 minutes. That will be Thursday morning. So on Thursday, we're going to come in here. We're going to start off with this and creating a single course page. We have to figure out pricing, or at least like how to deal with pricing. I'm probably going to start with preview first, and then we can move on to purchase. I'm not sure yet exactly how we're going to do purchase stuff. So that will be interesting too. Anyways, thank you everybody for hanging out with me today. Hopefully it was, with the ECS stuff, was interesting. I certainly always find it interesting when I have to like delve into the bit shifting things. It's a nice puzzle usually in my mind. So with that, I will see you all on Thursday morning for more LMS work. Thank you everybody, and see you then. Bye.